Hi everyone, in this lecture we'll talk about another searching algorithm which is known as binary search. Okay, so what is this binary search? We'll discuss. So it's an algorithm that works on sorted arrays. Okay, so that means sorted means the elements are arranged in the alphabetical order, or if it is integers they are either arranged in increasing order or in decreasing order. Okay, so let's take the same restaurant example again. Suppose you go to restaurant, but this time your menu is arranged in the order in which the items are in the alphabetical order, let's say. Okay, so maybe we have a burger, maybe we have a coke, maybe we have a dosa, maybe we have a Maggie, we have, let's say, pizza. Okay, let's say these are the items we have, and let's say something, maybe a soup as well. Now you can see these are arranged in the alphabetical order, so we also call this as a lexicographic sorted order. And maybe you want to search for an item, let's say pizza. Okay, and somehow randomly you, instead of start iterating from the index 0, you suddenly directly look at dosa. Okay, and you know the menu is arranged in a proper order and you want to go for pizza. So what you will do in that case, you will never scan this list. You know, if it is arranged in a proper order, then pizza must come after dosa. So maybe what you do, you start iterating from here. Okay, maybe you search in this particular part. So this is the whole idea of doing binary search. Let us discuss the exact algorithm, and it will help us to save time if the array is sorted array. Okay, so let's say this is how the array looks like. And what binary search will do, binary means 2. Okay, so what we will do, we will divide the array into 2 parts every time by the middle element. Let's say we are looking for an element that is, let's say, 19. Okay, we want to search for 19. So what we do, we know this is the starting point of the array, this is the ending point of the array. So we find out what is the middle element in the array. Okay, so the middle element is 11, so we will divide this array by the midpoint. Okay. Now if this is the array, so this is the middle point, we are looking for 19, and this array is a sorted array. Okay, so this should be 30. Just there is a small mistake here, this should be 30. So this should be 30, and let's say we are looking for 19. So 19 must lie to the right of the mid. So what we do, we discard this part of the array. Okay, so out of n elements, we reduced our problem to a size of n by 2. Okay, next time what we are going to do, we are going to say, okay, you should search only in this part of the array. So that means the start will come here, and we are not worried about this mid and this start. This is now obsolete for the next iteration. So what we do again, so we again do the same work. We find out the midpoint. This time we have a smaller array, 19, 29 and 30. Okay, so we know this is the midpoint and we are looking for 19. Okay, and this is end, this is start. So we are looking for 19, that means this must come to the left of the mid. Okay, so we discard everything that is there on the right of the mid, including the mid itself, because mid is not equal to 19. Okay, so what we do, we bring our end to this particular part. So we say, okay, now we have this is the first iteration, this is the second iteration. In the third iteration, what we have start, we have end, both of them point to 19. Okay, and what we are looking for, we are looking for an element that is equal to 19. So we find out the midpoint, and we see this midpoint exactly contains the value that we require. Okay, so we actually return this particular index. But suppose instead of 19 we were looking for 20. Okay, so till now the first step would be same. Midpoint is 11, go to right, we will get this array. In the second step, midpoint is 29, it will say go to left, and we will again get 19. So at this point what we will do, we will say we are looking for 20, but the middle point is 19. So that means it must come to the right of this particular element. Okay, so what we do, we simply do start equal to mid plus 1. Okay, start equal to mid plus 1. So in that case, what is going to happen, end is going to remain here, the start is going to come here. Okay, the start is going to come here. So as soon as this happens, that means start becomes greater than end. That means this element is not present. Okay, so that means if this happens, then we can say the element is not present inside this particular array. Okay, so what will happen? You start from an array of size n by n, then it will reduce to n by 2, then it will reduce to n by 4, then it will reduce to n by 8, eventually it will reduce to 1. If that element is not equal to what you expected, your this condition will get hit. Okay, either end will come before start or start will come before end. In that case, we can say element is not present. Okay, so that means we reduce it to size of 0, that means not found, and here we can say the element is found. Okay, we will return the index, whatever index we have. This may or may not happen. Okay, going from 1 to 0 may or may not happen. Okay, so this is what the binary search algorithm is all about. Okay, so now let us summarize what we discussed. Okay, so algorithm summary: we will need a start that is set to 0, we will need an end that is set to n minus 1 in the beginning, and we need to do certain work again and again. So we will have while what start is less than equal to end. Okay, that means when start exceeds end, break this loop, find the midpoint. Okay, so midpoint is very easy. You simply do start plus end by 2, and you do a comparison at the mid, do comparison at the midpoint, and from this comparison you can have three things: either the element can be equal to mid, or it can be greater than mid, or it can be less than mid. Okay, so accordingly you will move left or right. Okay, so in the next video we will see the exact code, but this is on the high level what we are going to do in the algorithm. If we are out of the loop, we can say return minus 1, and if it is equal, we are going to say return the midpoint. Okay, this is what we are going to do. So if the midpoint is greater, okay, so if we say, okay, if the midpoint is greater, then what is expected? Let's say we are looking for 2. Okay, in that case what we will do, we will move this end from here to here. Okay, so that means we will move end towards mid minus 1, but we are looking for 19. That means element is greater. We will move our start from start to mid plus 1. That's what we are going to do. So let's see the code in the next lecture.